Up on that front page, we said that functions may be defined by a set of ordered pairs, which we just did in example 1a, and by a table, which we went over in example 1b. We're still going to go over graph equation and verbal description, but before we go over those, first, we need to talk about function notation since we are talking about functions. We're going to be using function notation quite a bit in this class. So, function notation, the big thing here is that my y equals f of x. Those mean the exact same thing. Y equals f of x. Okay, and this reads y as a function of x. And that little vocabulary right there is going to be really important when we get to our verbal description. So y as a function of x equals this right here. Y as a function of x. Okay. And this is a way of representing a relationship between two variables. The letter x represents the input or your independent variable, which is what we went over in that table on that first page. And the letter y is replaced by f of x, which reads f of x, and is represented by the output or the dependent variable, which again we went over in that previous table. So here's some function notation right here. First, you have the name of the function. So here we have f of x. Now, f and x, those can change. So we can also have g of x is a common one that we can use. We can use h of x is a common one we can use. A lot of times we will be using x, but that's not always the case. We could have something like p of t. Okay, so the variables can change, but I would say f of x is the one that we're going to use the most frequently. Now, whatever is in parentheses here is your input or your domain. So here my domain would be x. These would also have a domain of x. This one would have a domain of t. And then your output is whatever this equals. So you will substitute that value in for x and then evaluate it. So example 2, let's use function notation. It says, given the function f of x equals negative 3x plus 5, find each of the following. Okay, so notice that this was f of x. It is now f of 2. So that means that is what my x equals. So I'm going to go into this function and I'm going to substitute in whatever x equals. In this case, it's 2. So this is negative 3 times 2 plus 5. Now, honestly, you can put that in your calculator just the way it looks and you can evaluate it. Or you can use your order of operations, which says we're going to multiply first. So negative 3 times 2 is negative 6. And negative 6 plus 5 gives me negative 1. So we have f of 2 equals negative 1. So here is what it equals. Now, I want you to understand that this right here represents an ordered pair. This right here represents the ordered pair of 2 comma negative 1. This is my x value, and what f of x equals, this negative 1, is then my y value. Okay, let's do it again with this one here. Now they're telling me my x equals negative 7. I'm still using the same function. Now I'm replacing that x with negative 7. So we've got negative 3 times negative 7 plus 5. Again, you can put negative 3 times negative 7 plus 5 in your calculator, but this one's not too bad, again, to just do by hand. Multiply first, so negative 3 times negative 7 is a positive 21. And 21 plus 5 gives me 26. So this is the value of it. This is my final answer, 26. But I want you to, again, understand that this represents an ordered pair. My x is negative 7. And what this equals is my y, is my output. So that is the ordered pair that we would have that goes with that function. Okay, example 3. It's the exact same thing. It's just now my function changed. So given the function h of t equals 10 minus 16x squared, find the following, or find each of the following. So now we have h of negative 3. So because this is h of t, this right here is my value for t. So actually, before you get to this, I will change this problem here. This needs to be a t. Okay, so I'll make sure that's changed, hopefully, before you get to this. So notice that now my variable is a t. So they're telling me here that t equals negative 3. So I will replace this t here with negative 3. So now I have 10 minus 16. When we substitute in, it's really important that you substitute in with parentheses. So this will be negative 3 in parentheses squared. Okay, order of operations tells me to do exponents first. So we have 10 minus 16 times negative 3 in parentheses squared is positive 9. Okay, here is why it is so important that you put this in parentheses. If I don't put parentheses and I just do negative 3 squared, that comes out to a negative 9. But when I put parentheses, that becomes positive because negative 3 times negative 3 becomes a positive 9. So always substitute in with parentheses and be careful with that. Okay, continuing on, we will multiply now. So 16 times 9 is 144. And 10 minus 144 is negative 134. So this is my answer, but this still represents an ordered pair. This would be negative 3 comma negative 134. Okay, here is my input. Here is my output. Now again, I've said this, but to show you, you can, once you substitute this in, you can put this all in your calculator. So 10 minus 16 times negative 3 in parentheses squared gives me a negative 134. So if you don't want to work that out by hand, you don't have to, just put it on your calculator. Okay, last one here. Part B, we're going to find h of 0. So this is my new t. So replace this t with 0. So we get t minus 16 times 0 squared. This one is very, very straightforward. 0 squared is 0. 0 times 16 is 0. This whole thing will reduce to 0. So now I have 10 minus nothing. So my h of 0 equals 10. So what is this as an ordered pair? My input, what I plugged in, was 0. And what it equals is 10.